The last two theorems that we're going to write proofs on are angle, angle, side, and angle, side, angle. So let's start with angle, angle, side. Hang on there. Let's do this a little bit differently. There we go. We have a proof, and it tells us that side AD is perpendicular to side ME. So I marked that on my diagram. Now that I know that, I am going to write everything that they've given me in red and everything that I can prove in blue. So now that I know that AD is perpendicular to ME, I can prove that line or angle A is congruent to angle ME. And the reason I can do that is because they're corresponding angles. Now, if you can't see this, I want you to draw this off to the side without all of the other stuff. Just draw your two parallel sides, AD and ME, and your transversal AB, and you can see that angle A and angle, sorry, I can't see this, EMB are corresponding angles. Another thing they've told me is that side DM is parallel to side EB. And because those two sides are parallel, I can say that angle B is congruent to angle DMA. Again, because they are corresponding angles. And also, do this if you need to. Draw those two parallel lines on the transversal AB, and you can see that angle DMA and angle B are corresponding angles. So if I've got those two corresponding angles, and then the last thing they've given me is side AD is congruent to side ME, then I can prove these two are congruent with angle, angle, side. So let's write down what we have talked about. I'm going to say that angle A is congruent to angle EMB because they are corresponding angles. So the corresponding angles theorem is my reason. And angle DMA is congruent to angle B also because of the corresponding angles theorem. Now let's go back and check. I've got one non-included side and two angles. So I can say that triangle ADM is congruent to triangle MEB because of angle, angle, side. Now, I want you to pause your video and try this next one. Now, I know it's very tempting when I say pause your video to just let it keep rolling and you write down everything I say. But on the unit test, I am going to give you proofs that you must do on your own. So if you've never actually tried one on your own, it's going to be very, very difficult. So I encourage you to actually pause the video and try this proof. So pause your video now. Now that we have come back, they have given us that side AB is congruent to side ED. And again, I'm going to mark the things they've given me in red and things I can prove in blue. They've also given me that angle A is congruent to angle E. Well, looking at this diagram, I can see that I can easily prove that angle BCA is congruent to angle DCE because they are vertical angles. And if I do those things, write down my givens, and prove those vertical angles, then I will have angle, angle, side. So let's do that. Let's say that angle BCA is congruent to angle DCE because of vertical angle theorem. And then let's go back and check. I have two angles that are congruent, two sets of angles that are congruent, and a set of non-included sides. Therefore, triangle ABC is congruent to triangle EDC because of angle, angle, side. Now, the very last theorem that we are going to use to prove triangles are congruent is angle, side, angle. Now, in this diagram, I have been given that angle XYZ is congruent to angle WZV. So I'm going to mark that with red. Then I am told that side XY is perpendicular to side YZ, and side WV is perpendicular to side ZV. Well, I can't really mark that on my diagram, but what I can prove because of that, I'm going to mark in blue, is that those two perpendicular lines form right angles at Y and V. And then they also give us that side YZ is congruent to side VZ. So I've marked that. And when I look at my diagram with what I can prove and what they've given me, I have side, angle, side, because I can say that all right angles are congruent. All right, so let's write down what we know. We know that angle Y and angle V are right angles. And the reason we know there are right angles because that is the definition of perpendicular lines. Two lines that intersect to form right angles. Now that I know they're right angles, I can say that angle Y is congruent to angle V because of the right angle congruence theorem, which says all right angles are congruent. So let's go back and check. I have this set of angles, that included side, and this set of angles, and therefore I can say that triangle YXZ is congruent to triangle VWZ because of angle, side, angle. Now, I would like you, again, pause your video and give a stab at this particular proof. Pause your video now. I would like to write in blue everything I can prove. And they are telling me that side PR bisects angle QPS and angle QRS. Well, I can't really write down bisect on my diagram, but because I know that segment bisects those two angles, I can prove that angle QPR is congruent to angle SPR. I can also prove that angle QRP is congruent to angle SRP. And then I can always prove that PR is congruent to itself using reflexive property. And if I do all of those things, I will have angle, side, angle. So let's write this down. I'm going to write that angle QPR is congruent to angle SPR. And the reason those two angles are congruent is because PR is an angle bisector. So the definition of angle bisector. I can also say that angle QRP is congruent to angle SRP because of the definition of an angle bisector. And then lastly, of course, I'm going to say that side PR is congruent to side PR because of the reflexive property. Once I've said these three things, this angle, the included side, and this angle, then I can say that triangle PQR is congruent to triangle PSR by angle, side, angle. Now, I think you have enough information that you can start your practice. So why don't you start that now?